So you know how the particles in solid are arranged, and then how about liquid and then gas. Okay, so if you can see from for solid, the particles are arranged very closely to each other. So it is rigid, uh, and it has a fixed shape and fixed volume. For liquid, the particles are not rigid, so they have some space between each other. Okay, so it doesn't have a shape, so no fixed shape. It follows the shape of a container, and then it has a fixed volume. Okay, and then for particles for gas, they are very far apart from one another, and it has no fixed shape and no fixed volume. Okay, so properties of gas. Okay, so today we will focus only on gas. Okay, so for gas, it has no definite volume and no fixed shape. Okay, so the particles are very far apart from one another. Okay, and then the size of particles are much smaller when compared to the volume of the container. Okay, so explain qualitatively the basic assumption of. Okay, so this is the first learning outcome. You have to be able to um, make assumptions. Okay, so explain the assumptions in kinetic molecular theory of gases for an ideal gas. Okay, so there are a few basic assumptions made in kinetic molecular theory of gas. Okay, so this kinetic molecular theory of gas is used to explain ideal gases. Okay, so most gases are real gases, tapi for this one, for kinetic molecular theory of gases, uh, dia they assume that these gases are ideal gases. Okay, so we will look at a few assumptions made in kinetic molecular theory of gases. Okay, so the first one. Okay, so for an ideal gas, okay, so the gas molecules are in continuous and random motion. Okay, so these gas molecules, they always move around. Okay, and then it always moving in random motion and so random motion and continuous. Okay, constant moving in no particular direction. They frequently collide each other and with the walls of container. Okay, so it moves around very randomly. They can collide. These particles can collide with one another, or it can um, collide with the, or it can collide with the walls of the container. Okay, so the second assumption is that the collision between molecules are elastic collision. Okay, so if they collide with the walls or if they collide with particles and particles, okay, so they are these collisions are elastic. So that means it will bump back lah. Dia takkan, so it's not, dia takkan melekat macam tu. Okay, so the collisions are elastic collision. Okay, there is no loss in kinetic energy. So kinetic energy before collision are the same after the collision. Total kinetic energy is constant. Okay, so there is no loss in kinetic energy. Okay, so the third assumption we made is the volume of gas molecule is negligible compared to the volume of container. Okay, so since these gas molecules, these gas particles, they are they are very far apart. So we can assume that these gas molecules are negligible. So we just take the volume of the container. Okay, so this because these particles are very far apart from one another, so they are um, so this we assume that the volume of gas is negligible as compared to the volume of container. Okay, so dia insignificant lah. So this gas volume are insignificant. Size of gas particle are much smaller than the space they occupy in the container. Okay, and then the fourth assumption we made is the intermolecular forces between gas molecules are negligible. Okay, so again, because they are very far apart from one another, so there is no attraction forces lah between this gas particle. So we can assume that the intermolecular forces between gas molecules are negligible. Okay, and then number 5, average kinetic energy of gas molecules is directly proportional to absolute temperature of gas molecule. Okay, so the kinetic energy, average kinetic energy is directly proportional to absolute temperature of gas molecule. Okay, so um, this is in cool gas. Okay, so there is fewer and less energetic collision. So in cool condition, so this gas particle, they did not move as much as in hot condition. So in hot condition, they collide. So if the temperature increase, they will collide one with one another more rigorously lah. Okay, so so it is directly proportional. As we increase the temperature, so this kinetic energy also increases. Okay, so pressure of gas. Pressure exerted by a gas is caused by the collision of gas molecules with the walls of container. Okay, so because the gas molecule collide with the wall of container, so it will produce the pressure for gas. Okay, pressure force area. Okay, so ni adalah pressure lah. Atmospheric pressure 1 atm is equal to 760 millimeter mercury or 760 torr. 1 atm is also, so if you convert this in Pascal, it is 101.325 kilopascal. So these values are given in your list of formula in front of your exam sheet nanti. So yang ni conversion ni dia akan bagi dalam exam. Okay, so so we will look at the few gas laws. Okay, so the first one is Boyle's law. Okay, so Boyle's law. Okay, at a constant temperature and number of mole, the volume of fixed mass of gas. Okay, so you have to be able. So according to this learning outcome, you have to be able to define Boyle's law. Okay, and then you have to be able to sketch and interpret the graph of Boyle's law as well. Okay, so definition you have to be exact lah. So kena ikut ayat dia yang betul-betul, define Boyle's law, and then you have to be able to sketch the graph for Boyle's law. Okay, so for Boyle's law, at a constant temperature and number of mole, the volume of fixed mass of gas is inversely proportional to its pressure. Okay, so in Boyle's law, the volume is inversely proportional to its pressure. So given that the temperature and the number of mole are constant. Okay, so N is for number of mole, T is for temperature. Okay, so if we bring this pressure here, so we get PV equal to a constant K. Okay, so K is a proportionality constant. Okay, if you are given two different pressure and volume. Okay, so kita daripada sini tadi kita ada PV equal to K. So if we have different pressure and volume, so this you can use this formula P1 V1 equal to P2 V2. Okay, so this is for the same gas. For the same gas, so number of mole is constant and the temperature is constant. So if we change, so we can use this one P1 V1 equal to P2 V2. So let's say so V1 is the initial volume, P1 is the initial pressure. Okay, so let's say kalau gas tu kita pindahkan dekat volume yang berbeza, V2. So you have to find what is the final pressure. Contoh macam tu lah. Ataupun if you gas yang sama tadi kita pindahkan dekat container with different pressure, what happens to the volume? So you can use this this formula P1 V1 equal to P2 V2. Okay, so this one you can use if you are given two different pressure and volume. Okay, so and then you have to be able to sketch the graph for Boyle's law. Okay, so graph of volume against pressure. Okay, so it is inversely proportional. So you have this kind of graph. Okay, so if you plot, if you sketch, so you don't have to plot, so just sketch. So volume and volume against pressure. Okay, so you get this kind of graph because they are inversely proportional. Okay, so if you sketch a graph of volume against 1 over P, you will get a linear. Okay, so sketch a graph of 1 over P, you'll get a linear. Okay, and then, so macam yang ni kita dapat kan PV sama dengan K kan? Sama dengan K. So if we buat Y equal to MX plus C. Okay, so we bring V. So to plot V K times 1 over P. Okay, so plus C to 0 lah. Okay, so you get, so this one, if we compare, so this is Y. So volume is Y. K is the gradient. That is a constant. Okay, and then 1 over P is X. Okay, so if we plot, okay, so we will get a linear. Okay, so and then if you plot PV against pressure, okay, so you will get a constant. So because PV is equal to K tadi kan, so K is a constant. So you will get a constant graph. Okay, so next, you have to be able to define Charles' law. What is Charles' law? And then sketch and interpret the graph of Charles' law. Okay, so according to the definition of Charles' law, at constant pressure and number of mole, the volume of fixed mass of gas is directly proportional to absolute temperature. Okay, so volume of fixed mass. So volume is directly proportional to the absolute temperature. So volume is directly proportional to the temperature. Okay, so fixed mass of gas, so number of mole is constant and the pressure are also constant. Okay, so if we bring T to the left hand side, we will get V over T equal to K is the proportionality constant. Okay, if you are given two different temperatures and volume, okay, you can use this formula V1 over T1 equal to V2 over T2. Okay, so let's say if you are given V1, the initial volume and initial temperature. Okay, so at different temperature, what happens to the new volume? What happens to the final volume? So you can use this formula. Okay, and then to to sketch the graph. Okay, so graph, if you sketch a graph of volume against temperature in Kelvin, okay, so it must be proportional to the absolute temperature. So absolute temperature must be in Kelvin. So if you sketch a graph of volume against temperature in Kelvin, okay, you will get a linear straight line, and it will intersect at 0. So if you sketch a graph with temperature in degrees Celsius, so it will intersect until you get, so when V is equal to 0, so you will get it will intersect at negative 273.15. So this is because sebab dia punya volume is directly proportional to absolute temperature. Okay, so calculation kalau kita pakai Charles law, kita kena make sure you have to change the temperature in Kelvin. So 0 Kelvin is 270.15 degrees Celsius. Okay, so let's say kalau dalam soalan dia bagi dalam degree Celsius, so you have to do the calculation, you have to convert into Kelvin first. Okay, and then we have a combined gas law. Okay, so combined gas law, if we combine Boyle's law and Charles' law. Okay, so from Boyle's law, volume is inversely proportional to pressure. From Charles' law, volume is directly proportional to temperature. So if we bring this together, we will get volume is directly proportional to temperature but inversely proportional to pressure. Okay, so if we have at different condition, so you can use this formula P1 V1 over T1 equal to P2 V2 over T2. Okay, so next we will look at Avogadro's law. Okay, so Avogadro's law, so what's constant is temperature and pressure is constant. Okay, so what happens is that the volume of fixed mass of gas is directly proportional to the number of mole of gas present. Okay, so the volume is directly proportional to the number of mole. Okay, so Avogadro's law, so these two are constant, temperature and pressure. So volume is directly proportional to number of mole. Okay, so ni kalau kita bawa to the left, so V over 1 N equal to K. So if we have different volume and number of mole, we can use this formula V1 over N1 equal to V2 over N2. Okay, so if you sketch a graph of volume against number of mole, you will get a linear because they are directly proportional. Okay, so next we will look at ideal gas law. Okay, so how to derive this ideal gas law? So we just combine Boyle's law, Charles' law and Avogadro's law. Okay, so ideal gas law equation describe how V of gas, volume of gas is affected by changes in pressure, temperature and number of mole. Okay, so we combine these three laws, we will get volume is directly proportional to number of mole, directly proportional to temperature and inversely proportional to the pressure. So we bring pressure to the left, we get PV directly proportional to NT. Okay, so and then we have to put, so to make it an equation, we have to put a constant, and the constant is R. So R is a gas constant. So usually I will use this one, 0.08206. So make sure if you want to use this gas constant, make sure that the volume is in liter, the pressure is in ATM, the temperature in Kelvin. Okay, so number of mole is mole lah. Okay, or if you use the pressure in joule, so you can use this one, 8.314 joule per Kelvin per mole. Okay, so ideal gas equation can be used to calculate pressure. Okay, so kita boleh pakai ideal gas equation tu untuk calculate pressure. So pressure, ideal gas equation is PV equal to nRT. So to get pressure, so just nRT over V, sorry. Okay, and then we can use ideal gas equation to calculate temperature. So if we have PV equal to nRT, so to get the temperature, so it is PV over number of mole times the gas constant. Okay, and then we can also calculate the molar mass. Okay, so molar mass PV equal to nRT. Okay, so we know that number of mole is mass over mR, molar mass. Okay, so if we substitute this into our ideal gas equation, we will get PV equal to M mass over mR, molar mass, times RT, gas constant, and T temperature. So to get the MR, the molar mass, so it is MRT over pressure times volume. Okay, so for density, okay, so we have ideal gas equation, PV equal to nRT. Okay, so N is mass over mR. Okay, so ni sama macam tadi. So PV equal to, so we substitute number of mole, mass over mR, RT. Okay, so nak dapatkan density. So density is mass over volume. So we can bring this pressure times with the molar mass, PMR, equal to M over V RT. Okay, so M over V is mass over volume is the density. So we can also calculate density. So we have pressure times molar mass. Okay, so this is the density times RT. RT. Okay, so to get density, so density it is pressure times molar mass divided with RT. Okay, so this is how you can get the density of gas. Okay, so these are the things that you need to remember. Okay, so this formula. Okay, so for Boyle's law. Okay, so basically, cara nak ingat dia, we have A, B, C. So we have Avogadro, A Avogadro, B Boyle's law, C Charles law. Okay, so for Avogadro, uh, temperature and pressure is constant. Okay, and then for Boyle's law, temperature and number of mole is constant. Okay, and then for Charles law, pressure and number of mole is constant. Okay. So cubalah so you have to remember this one. Okay, so untuk Avogadro, temperature and pressure is constant. Boyle's law, temperature and number of mole, and Charles, pressure and number of mole. So macam mana cara nak ingat? So pendapat ikut kreativiti awak lah macam mana cara nak ingat. ABC ni senang. TP, TN, PN ni, so you can ikutlah kreativiti masing-masing macam mana nak ingat this definition for Avogadro, Boyle's and Charles law. Okay, so how you can remember this formula? Okay, so kalau we have our ideal gas equation which is PV equal to nRT. Okay, so sekarang let's say kita nak ambil tengok Boyle's law kan. Okay, let's say kita nak tengok Boyle's law. So Boyle's law, temperature is constant, number of mole is constant, R is constant. Okay, so you have to relate between pressure and volume. Okay, so for Boyle's law, it is, so you can use P1 V1 equal to P2 V2. Okay, and then how about Charles law? So let's say Charles law, PV equal to nRT. Okay, so dekat Charles law, pressure is constant, number of mole is constant. Okay, so R is obviously a constant. So you can relate volume and temperature. So we get V1 over T1 equal to V2 over T2. Or you can say that volume, so at constant pressure and number of mole, so volume is directly proportional to the temperature. So volume is directly proportional to temperature. So this is how you can remember your formula lah. Okay, so that is for Charles law. You can use V1 over T1 equal to V2 over T2. Avogadro, V1 over N1 equal to V2 over N2. Combined gas law is P1 V1 over T1 equal to P2 V2 over T2. So this is ideal gas equation. Okay, so just ingat yang ni, and then ingat ni, you can derive. You can even you can give the definition, and you can even derive the other formula lah. So tak perlu nak ingat satu-satu. Okay, and then for molecular mass of gas, okay, so molecular mass of gas, so MR, tadi kita dah derive kat atas, MR, okay. So MR is MRT over PV. And okay, and then the density of gas is density is equal to VMR. Okay, so ni daripada yang tadi kita dah tengok dah kat atas tadi. So to get density of gas, it is PMR over RT. Okay, so okay, so for so who wants to try? So which graph for this exercise, which graph is correct for a given mass of an ideal gas at constant pressure? Okay, ada siapa nak cuba? Which graph is correct for given mass of an ideal gas at constant pressure? At constant pressure. So A, jawapan dia A ke B ke C ke D? So this one is B, ni C ni D. Jawapan dia A. Okay, so at constant pressure, which graph is correct for a given mass of an ideal gas at K? Kita ada ideal gas equation PV equal to nRT. Jawapan awak A So constant pressure, so given mass ni maksudnya the number of mole is constant. So R is a constant. So kita kaitkan volume dengan temperature. So volume is directly proportional to temperature. So yes, the answer is A. So volume is directly proportional to temperature. So you will get a straight line graph, a linear graph. Okay, so who wants to try? State the law described in picture A, B and C. Okay, picture A first. For picture A, what is the law involved for picture A? Avogadro ke, Boyles ke, Charles ke? Untuk picture A dulu. Okay, so from picture A, we can see that the temperature is constant. Temperature, if you look at the thermometer reading, is the same. So what's different is the volume, different, and the pressure is different. Ni pressure dia, reading dia lain. So which gas law involved for picture A?
Boy's law.
Boy's law. So Boy's law Okay, so kita ada PV equal to nRT tadi kan. PV nRT. Okay, so temperature dia constant. Temperature constant. And then R is a constant. Number of mole is constant. Okay, so number of mole, how I know it's constant? Tengok zarah ni, the particles, nilai particles dia sama. So number of mole is constant. So pressure is inversely proportional to volume. Okay, so which one is for this one? So kita ingat balik tadi lah yang saya cakap tadi. How you can remember is you have A, B, C and then T, maybe tuan pengarah ke, timbalan pengarah ke. Okay, and then TN, so TN tuan-tuan dan puan-puan. Tu cara saya ingat lah. Okay, so untuk Boy's law, so if we look at Boy's law, temperature is constant and number of mole is constant. Okay, so betul lah. So for picture A, temperature constant, number of mole is constant. Temperature constant and number of mole is constant. So this is Boy's law. Okay, so how about B? So is it Charles So dekat Charles, pressure dengan number of mole. So pressure dia sama, number of mole sama. Okay, so betul lah. So this is Charles. Okay, so for C, Avogadro. Dekat Avogadro, temperature dia constant, pressure constant. Pressure constant, temperature pun constant. Okay, so this is Avogadro. Okay, so basically senang ingat. You can ingat yang ni lah ABC. Tuan pengarah ke, tuan-tuan dan perempuan ni. Okay, and then ingat PV equal to ideal gas law. PV equal to nRT. Okay, so yang lain tu you have to be able, yang lain tu contohnya molar mass, itu kena pandai derive lah. So you know that molar mass is mass over number of mole. Okay, so number of mole, sama dengan mass divide with molar mass. Okay, so mass substitute dalam ni kita boleh cari molar mass pakai kita punya ideal gas equation. Okay, and then so density, mass over volume. So yang ni kena pandai derive kalau nak dapatkan density and also molar mass. Okay, so next.
Madam,
Ya?
yang nombor 1 tadi kan, bukan C ke? Sebab dia punya temperature degree Celsius.
Volume. Oh sorry, lah betul. Sorry. So sepatutnya, jawapan dia adalah C. Okay, correction So C, betul C. Sebab temperature untuk ni Charles law tadi Charles law ke apa? Volume dengan temperature. Okay, Boy's law. Okay, constant pressure. So this one is Charles law kan? So Charles law, volume is directly proportional to temperature. Bukannya directly proportional to temperature. It is directly proportional to absolute temperature. So absolute temperature maksudnya temperature tu must be in Kelvin. So since dia plot dia sketch a graph in degree Celsius. Okay, so dia kena actually dia sampai sini dia tak intersect dekat zero. Actually the correct answer is C. Okay, so sepatutnya macam ni lah. So dia akan intersect dekat negative 273.15. Okay, so thank you betulkan. Okay, jawapan dia C sebab dia absolute temperature. Okay. So boleh try lah these questions. Okay, so ni dah masuk the learning outcome 5.1 D and E. So you have to be able to perform calculation using gas laws dengan ideal gas equation, which is PV equal to nRT. Okay, and then find molar mass of volatile liquid using ideal gas equation yang from derivation yang tadi kita buat. So MR sama dengan apa tadi? Mana tak ingat dah. Kalau tak ingat just derive lah. MR sama dengan MRT over PV. MR sama dengan MRT over PV. Okay, so kita tengok dulu example of the first one. A sample of chlorine gas occupies a volume of 946 ml. Okay, so it's very useful if you write the information. So what you can do is you have to write the information. Okay, so you are given the initial volume 7. Initial volume 946 ml at a pressure of 7 to 6 millimeter mercury. So what is the pressure of gas in millimeter mercury if the volume is reduced? Okay, so now the new volume is 154 ml. So what happens to the you have to find what is the pressure, the final pressure. Okay, so make sure you write this one. So it's you take out the information, okay, and then you can use the formula. It's reduced at constant temperature. Okay, so constant temperature. Okay, so kita ada, kalau tak ingat lah, PV nRT. So number of mole is because it using the same gas, so number of mole is constant, temperature is constant, R is a constant. So you can use P1 V1 equal to P2 V2. P2 V2. Okay, so just substitute the value. So bila kita dah keluarkan information, senang nak substitute the value. So P1 is 7 to 6 millimeter mercury times V1 is 946 ml. So to get the new pressure, we substitute the final P1 V1 equal to P2 V2 ni. Okay, so final volume is 154. So kita akan dapat pressure in millimeter mercury, which is 4459.7 millimeter mercury. Okay, so I hope you have your calculator with you. So cuba try soalan number 2. A cylinder contains a gas at 5.25 atm pressure. When the gas allowed to expand to a final volume of 12.5 liter, the pressure dropped to 1.85 atm. What was the original volume of the gas? Okay, so cuba buat this question and then give me your final answer. So what is the volume of the gas? Okay, so I will help you to take out the information. A cylinder contains a gas at 5.25 pressure. Okay, so P1 is 5.25 atm. Okay, when the gas allowed to expand to a final volume, V2 is 12.5 liter. The final pressure becomes 1.85 atm. So we want
Madam,
yes.
the answer is 4.40.
4.40. Yes, okay, correct. So the answer V1 is equal to 4.40 boleh, 4.41 boleh. Yang saya kira 4.405 liter. Okay. So plus minus 0.01 boleh lah. Okay, so 4.41 liter. So that's correct. So boleh So ni pakai formula apa? Awak pakai formula apa?
Boy's law.
Boy's law. Apa dia formula dia?
PV equal to PV.
P1 V1 equal to P2 V2.
P2, yes.
P1 V1 equal to P2. Okay. Okay, so kita cuba a sample of carbon monoxide gas occupies 3.2 liter at 1 to 5 degrees Celsius. At what temperature will the gas occupy a volume of 1.54 liter of the pressure remains? If the pressure remains constant. Okay, so sama jugalah PV equal to nRT. Okay, so pressure remains constant, R is a constant, and because it used carbon monoxide gas, occupies 3.2 liter. Okay, so volume initial is 3.2 liter. At what temperature will the gas occupy? Okay, so this one kita relatekan volume and temperature. So volume is directly proportional to temperature. So V1 over T1 equal to V2 over T2. So this one is using Charles' law. Okay, so dekat Charles' law, the pressure remains constant. Okay, so at what temperature will the gas occupy a volume of 1.54 liter if the pressure remains constant? Okay, so we have initial temperature 1 to 5. So make sure for Charles' law, for temperature, you have to convert into Kelvin. Okay, so you will get 198.15 Kelvin. Okay, so bila kita ubah volume dia jadi 1.54, so you have to find what is the temperature. So the new temperature, okay, so you can use V1 over T1 equal to V2 over T2. Just substitute the value and you will get temperature 191.61 Kelvin. Okay. So how about question number 4? Okay, so boleh cuba A sample of a gas has a pressure of 850 torr. So pressure P1 is equal to 850 torr. Sample of gas has a pressure of 850 torr at temperature 285 degrees Celsius. To what degree Celsius temperature must the gas be heated to double its pressure if there is no change in volume of the gas? No change in the volume of gas. So volume dia constant. So we want to find what is the temperature when the pressure is double. P2 850, if it's double, so times 2. So that 850 times 2 dapat berapa?
1,700.
1,700 torr. Okay. So dapat tak temperature dia berapa? Temperature in degree Celsius. Okay, so siapa yang dah kira tu boleh bagi tahu apa yang final answer yang awak dapat.
142.5.
142.5. Okay, 142.5 degree Celsius. Okay, ada lagi? Ada yang dapat lain selain daripada 142? Dalam soalan dia tanya dalam Celsius. Celsius dapat apa? 70? 570 degree Celsius. Okay, ada lain tak yang dapat selain daripada 142.5, selain daripada 570?
Dapat 1.2.5 je, madam. 142.5.
142.5. Okay, so yang dapat 142.5 ni pakai formula apa?
Saya rasa saya salah madam. Tak payah buang aja jawapan tu madam, salah.
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 Tapi ada sokongan tu.
Tapi saya rasa salah.
Hmm. Combined gas law. Oh, pakai combined gas law boleh? Okay, so tapi apa yang saya buat, okay, so kita tengok soalan ni, a sample of gas has a pressure 850. So pressure dengan temperature dia berubah kan. So we have PV equal to nRT. So pressure, okay, so yang maintain the same is, so R is a constant. So number of mole is a constant lah sebab kita pakai gas yang sama. Okay, no change in the volume. Okay, so volume dia constant. So we can relate pressure and temperature. Okay, so pressure is directly proportional to temperature. Okay, so you can, so if you write P1 V1 tu, so P1 over T1 equal to P2 over T2. P1 over T1 equal to P2 over T2. So P1, so kalau kita masukkan value tadi, P1 is 850 torr. So it's better if you write the unit as well. 850 torr divide with temperature 1. Okay, temperature must be in degree Celsius and in Kelvin. 285 plus apa kalau kita nak convert 273 kan. 273.15. Okay, so ni nak convert kepada Kelvin. Okay, so pressure baru 1700 torr. So dapat, so kita dapat temperature in Kelvin lah, T2 in Kelvin. So T2 dapat berapa? Okay, 116.3. 116. 1116 kan? 1116.3. So this one is in Kelvin. So the question asks you the temperature in degree Celsius. Okay, so nak daripada Kelvin nak convert, so minus 273.15. Okay, so dapat berapa? Okay, 1116.3 minus 273.15. So dapat 843 kan? Okay, so the answer is 843.15 degree Celsius. So that's the answer. Okay, so this is the answer. 843.15 degrees Celsius. Okay, so senang macam tu. Ya.
Kalau daripada awal yang T1 tu, T1 saya tak tambah dengan 270.15. Nanti kan akhirnya tak payah tolak lagi.
Yang T1. Oh,
Tu kena tambah juga.
boleh ke? Cuba kalau kita maksudnya kalau ambil 285 je.
Sekejap saya try.
Cuba dulu.
Dapat 570.
Oh, 570.
Oh,
So kalau temperature memang kena convert. Memang kena convert absolute temperature. Kena convert Kelvin.
Okay.
Okay. So yang itu. So temperature memang kena convert kepada Kelvin untuk calculation macam ni. Okay, so jawapan dia 843 lah. Okay, so I think I will make a stop here. So yang lain tu boleh cuba dulu. Okay, so saya bagi jawapan Okay, so untuk question number 6. Question number 6. So the answer is 2.228 liter. Okay, kejap determine the volume of zinc and excess of at STP when. Okay, so 2.228 ataupun 2.227 lah liter. So boleh ambil jawapan and then you can try the question at your own time. Okay, and then question number 9. Okay, so the final answer is 11.39 liter. So make sure you try it. Kalau tak ada siapa nak bantu lah. Okay, so question number 11. .375 liter. Sorry, 4.75. Okay, 4.75 liter. Okay, so question number 12. 30.94 gram. Okay, so number 14, 1.29 gram per liter. Okay, and then question number 15, 67.91 gram per mole. Okay. So for the remaining time, you can try these questions. Okay, so kalau ada masalah, you can contact me lah. Okay. Okay, so thank you very much.
Thank you, madam.
Thank you so much, madam.
Okay, welcome.
Thank you, madam.
Bye-bye.
Thank you, madam.
Bye.